shaping sustainable water solutions through nature-based and transdisciplinary approaches. So this event is co-organized by UNESCO ISP Secretariat and also with Poland through UNESCO Category 2 Center, European Regional Center on Ecohydrology of the Polish Academy of Sciences, ERCE PAS. Thank you, represented by Prof. Zalewski here. And we are very grateful today, together with us. We have the ambassador, the permanent delegate of the Republic of Poland to UNESCO in Paris, which is Mr. Mariusz Lewicki. I hope I spell your name correctly. Thank you to be with us here, and and also at the center to be together with us in organizing this session. So these side events aim to bring together all ecohydrology experts from around the world, and also to introduce our UNESCO ecohydrology demonstration site to all participants, of course, because we are very excited on this ecohydrology demonstration site. And we have our representative from 11 demonstration sites out of 63 ecohydrology demonstration sites of UNESCO. So at least like 20 or 30% of ecohydrology demonstration sites are with us today together. And of course, we have various experts also to be with us in the panelists. We have Professor Salvaskar also. We have from Water for All. We have also another keynote that I will introduce later. Yeah, from Water for All, Benjamin. Maybe later. Yeah, and then Professor from IASR. I mean, we have our partner for ecohydrology to be together with us also today. So to start with this session, I would like to invite the Mr. Mariusz Lewicki to give the opening remark. Please welcome.
Thank you very much. And our Deputy Minister of Infrastructure, Mr. Koperski, was about to be here to open this very timely and important side event. Unfortunately, due to some recent political developments back in our country, he has to be in Warsaw. But I'm very happy to address you on his behalf. And first of all, let me also express our deep appreciation to the colleagues, to you, Madam Friti, to your team, and to all colleagues from the Secretariat for your outstanding work. Because a letter S in UNESCO science does matter. It does matter because the science makes a true difference on the ground, and anyway, it is so much interlinked and interconnected with all other letters, because science is linked with culture, with education, with social sciences. And my colleagues have prepared a speech for the open, but I'm taking this liberty to skip it because I am a career diplomat. I'm not a scientist, but I find this topic, ecohydrology, extremely interesting, even for people just like me, because it's all about holistic approach. It's all about transdisciplinary approach. It's all about understanding that we cannot solve the challenges, and we are saving many challenges also in the field of hydrology, water, by not addressing these challenges in a very comprehensive way. And this is why the title of this event, which is Sustainable Solutions through Nature-Based and Transdisciplinary Approaches, is very much timely, and I look very much forward to listening to you. I look very much forward to learning a lot from you, how we can together tackle these challenges. And I'm also very happy that we are meeting here at UNESCO, because UNESCO is this unique catalyzing objective and role, as science is all about cooperation, is all about striving together to solve the challenges we are facing right now. So once again, thank you so much for being with us. Thank you for excellent scientists. I will not. You know each other very well, so I don't need to introduce. But I'm very happy to be Poland's ambassador to UNESCO, because I have an opportunity to meet such persons like you from academia, that making a huge difference to the world we are living in. So thank you so much.
Okay, so to start our sessions, maybe I would like to inform that this session is two-part, consists of two parts. The first part, which I will explain later. So the second part will be conducted after the tea break, that will be moderated by my another colleague, Mr. Giuseppe Arduino. So for this part, we will start with the keynote session. We have three keynote today, this afternoon. First will be presented by Professor Maciej Zaleski, and then the second keynote will be by Mr. Karl Masses-Wanzen, and then the third one will be by Mr. Antonio Donato Nobre. And then next slide, please. Just to brief info to show the agenda to the participants. And then after that will be followed by the panel sessions with 6 panelists that will be moderated by me. So that is for the first session. So now, without further ado, so I would like to invite our first keynote, which is Professor Maciej Zaleski, to present his keynote. So, yeah, I will also go down.
Thank you, Madam Chairman. Ladies and gentlemen,
Okay.
I have the pleasure to thank all the UNESCO staff for preparation of this symposium, but I would like to start my talk from the saying that all we know that we are facing now the dramatic challenges which are approaching planetary boundaries, which are also somehow enforced by changing climate change, and we know that water is a key factor to reverse the process, as the New York conference was underlining. However, we need a new approach, new paradigm. Next slide. And here we are showing that all traditional approach, conservation, restoration, is not enough. Conservation was good if it was 3 billion people and 12 billion carrying capacity. Restoration was enough, it was 6 million. Now we have to enhance sustainability potential, because we are approaching is almost 9 billion and 10 billion is carrying capacity. And we know from evolutionary ecology that clash, exponential growth of population with declining carrying capacity, always has a dramatic consequences. To avoid the clash, we have reversed the trend, declining carrying capacity, through the deforestation, homogenization, agricultural landscape, urbanization, emission of pollutants. And every strategy has two elements: elimination of threats and amplification of opportunity. And ecohydrology is science which helps to put together in systemic approach both. Next slide, please. And why I said that ecohydrology is becoming the rocket science, because relation man and environment now is like in physics quantum entanglement. It means two systems which are very dynamic, interacting, however hard to, let's say, quantify, analyze the impacts and the relation. And we have to define hierarchy of drivers, and we know water is first, but in reality, SDG depends on water ecosystem, because water ecosystem interplay determine life-supporting processes. This is water cycle, carbon, nitrogen cycling, energy flow, and all three determine habitats. And that's why we have to, if we want to achieve SDG, water ecosystem interplay is fundamental now. Of course, still keeping in mind that these interactions are mutually positive. Next slide, please. And always, if we want to really create desirable future, we have to understand evolution. Evolution of processes, evolution of thinking, and evolution of processes starting for conquest of nature through the conservation, restoration, regeneration, up to the enhancement. Just transdisciplinary science has a more ambitious goal. We have enhanced global carrying capacity, always starting from water, water biota, water ecosystem interplay. Next, please. Next one. Yes. No. Forward. And what ecohydrology brought to hydrology? Why we can really be helpful, ecohydrology can be helpful to solve this problem and challenge. First, by deductive model, they brought ecosystem metabolism to the hydrology. Why ecosystem metabolism is important? For two reasons. We have to optimize nature-based solution to advanced nature-based solution, and without understanding metabolism, which is different in different continents, we cannot do that. Second, if we want to increase resilience of the catchment, which will be supportive for IWRM, in this moment, again, we have to understand metabolism of the system. And this is a challenge for future, for young generation ecohydrologists. You have to think about this, how the system is pulsing. And second element of ecohydrology is dual regulation. It means evidences that understanding hydrology biota interplay, we can very efficiently and extremely low cost improve ecological status with economical feedback. This is case which I was showing many times, the manipulation of water level reservoir, changing biological structure, changing filtrators, and elimination of filtrators in scenario on the right immediately generate intensive toxic algal bloom, which means eliminate 60,000 people around 20-kilometer long reservoir 10 times, which has a consequences, $60 million. So you imagine, instead of 60, local society is getting 6 million. If we understand this impact, manipulating this way to increase yellow, it means the 5 filtrators potential, we change the patterns, also energy flow, and nice nutrient cycling in reservoir to more resilient, to less vulnerable to eutrophisation, to toxic algal bloom. And of course, there is many, let's say, related processes which can be, this can be reference point which has to be further discovered. Next one. And as I said, why dual regulation is so important? Because before, hydrology was focused on water supply, disturbance, flood, drought control. And however, dual regulation is just background for creation all set the nature-based solutions which are complementary with hydroengineering. And another challenge for us to really make the advanced science is creation hybrid. And here cooperation with IHR is big future for our cooperation because we have to integrate into systemic solution hydroengineering with nature-based solution. Next one, please. Of course, I said understanding evolution of science is first step to really solve the problem. This is showing how evolution of river ecology goes through the river continuum, floodplain pulse by Wolfgang Jung, land water ecotones, Neumann de Camp, up to transdisciplinary ecohydrology from river segment, river valley catchment, and also with all the approach, more and more ambitious challenges. This approach for sure has to be developed with big support artificial intelligence. Next one. And now, why ecohydrology rocket science? Because during these 30 years in UNESCO, step by step we were putting together, we were putting molecular biology, biotechnology, microbiology, phytotechnology, and next, of course, hydrogeology, limnology, hydroacoustics, geosciences, and this make two elements because we have a different ecohydrological sections: water plant soil interaction, land water ecotones and floodplains, freshwater ecosystem, and coastal zone, which was developed by Louis Cicciaro with Eric Wolański. And this is really need, again, artificial intelligence to put together and still harmonize with hydroengineering in systemic solution. So I think this is showing how big future on the front and how big challenge is on the front, young ecohydrologists. Next. And this systemic approach, of course, are integrating this nature-based solution, but also putting together into systemic according circular economy. We have to be compatible with the European Commission strategy, which is very wise, and also our focus on harmonization. The potential, that's why I'm very glad that we have a representative of Water for All, new chairman, and I hope he will take the floor also to inform us. And indigenous knowledge. This is things which start in ecohydrology. Peter Hihanosa with Super Giuseppe Arduino, and Mark Albarracin is going very important step further. Some colleagues from Spain, this is going. No, and as I said already, hybrid systemic solution, hydroengineering, this is big challenge, and this is something which now we are preparing with Professor Mossa and Tom Su, the policy statement document, which will be paving way forward how to put this according to integration. Next one, please. However, the paradigm change, this is most important. Here on the left side, we have a publication that was very prominent hydrologist 2 years ago. You see there is citizen, government, media, non-governmental organization, and they want to solve water management without ecosystem. This is paradigm lock. They still thinking that they, by sociocentric mechanistic approach, they can solve problem. No way. Ecohydrology, dual regulation, this advanced nature-based solution, expanding. It's not. Still, this is true, but has to be in bigger framework of this evolutionary ecosystemic approach and harmonized, integrated. Next one. Cost efficiency. Now, just Johannes Kuhlmann was telling that challenge is that SDG financing is not sufficient and predictions are more and more ambitious, but coverage of the demands are not very, let's say, easy. And that's why we need a low-cost advanced solution, and ecohydrology just provide this, because according classic Schaffer curve, restoration is much more difficult than, it's not returning the same pathway of ecosystem. And next one. And we in ecohydrology provide the tools for impact reduction. Next, please. Yes, yes. Like non-source pollution, but also resilience enhancement of the system. Resilience was up to now neglected in hydrology, and is a great potential which has to be used, just understanding this different interaction hydrology biota. Next one. And implementation. I will be imprudent now, and I will say that already implementation progressing all over the world, but also some implementation awarded. We create certain feedback with the European Commission, and some of our project generated idea, concepts in UNESCO through all of us, implemented thanks to UNESCO European Commission financing Life Plus. Next was awarded Best of the Best in Europe in 2000, and another project Best of Life Plus. Next one. And IWRM. All of this, what I show very briefly examples, are generating new dimension, new tools, new potential for IWRM. So this next one. And future. Professor Cicciaro is a person who built the future of ecohydrology by making a fantastic effort to provide opportunity for young people from all over the world to learn ecohydrology at different universities. And this is something which I think is example how modern, let's say, education should be done. And I will be expressing all our things. Luis, great thanks. Next one. And finally, brief summary. Transdisciplinary for enhancement. We have to enhance, not only restore, not only conserve. Dual regulation for life supporting system. really regulation in catchment scale. Culture education, we should use World Heritage Sites, Map Biosphere Reserve, Ecohydrology demo site, National Environmental Institution Initiative in IHP. This should raise scientific and cultural curiosity of society. We were just talking that scientific curiosity will be crucial to involve society in action. And also cooperation with IHR, Water for All, this is extremely important to build this synergy. Proactive law, policy, governments, top-down, bottom-up. Not only, science should be not only designed through the, let's say, scientists, but also some challenges defined by people who are responsible to society for solving the problem, and this interplay should be somehow used. Youth education already I solved. And finally, all of this will be in the book, which is already in processing in Elsevier, and you can read more, much more precisely than I produce here. And last one, finally, I would like to express the thanks for many people who are just build up everything what I very briefly introduced, because this is effort of 30 years. The international team, thank you, catalyzing, let's say, role of UNESCO, and big effort of the coordinators of ecohydrology program. Thank you, Elfitri. Thank you, Giuseppe Arduino. Thank you, Shabazz Khan. And thank you for the, still remember Fred Fournier, who was first man who started with this ecohydrology with Andreas Stolosinac. I don't know, Andreas has probably another session, but I would like to say that Andreas was the director of Division of Water Science, who just 30 years ago took the challenge, say, okay, let's start integrate ecohydrology in ecosystem. So I think this is also, I think we have to keep him in the thankful memory. I think that's all, and I'm very interested to listen now to our colleagues and everything what is done around the world with our joint, let's say, strategic goal to make more secure, more friendly world with sufficient water and healthy ecosystem. Thank you very much.
Okay, so thank you, Prof. Zaleski, for highlighting very interesting perception on ecohydrology, which is ecohydrology is not only the implementing nature-based solution, but also as a rocket science, because it is integrated science and to achieve more impactful and more resilient catchment by using nature-based solutions approach. So next, we will move to our interesting speakers. Next keynote speaker, which is Professor Karl Matthias Wanzen, the UNESCO Chair of Rivers and Heritage from Tours University, and ECOR Chairs Water and Sustainability. Please welcome.
Thank you very much. I'm starting my watch now, and you should take out your cell phones for some flashcodes that will appear if you wish. Maybe we can start now with my presentation on river culture, Ion River connectivity as a vehicle to transport these ideas of ecohydrology into society. So this first slide actually shows the Rhine near my hometown, and on this island my grandfather in the 1920s, he was a medical doctor, he treated the poor people there and they paid him with fish. So to say this is about developing. Next slide, please. So Maciej has just presented why ecohydrology is rocket science, but a question is how can we implement it, and culture and education are definitely a very important means to transport it. We cannot only use facts, and we cannot convince only with oxygen rates and so on. We also have to touch the people by their hearts. Next. People are connected culturally with water and water bodies in different ways. In a spiritual way, for example, here the Pachamama philosophy from the Andean countries that homologize the water cycle with the cycle of rebirth. So in the beginning of your life, the god Apu in the Andes, as long as glaciers exist, decides whether you can start flowing your life or if you have to wait a little bit until you end up in the sea and then are reborn via clouds. Next. And in many rivers, here on the left, people in the Pantanal, on the right, La Grande Remontée on the Loire, by cultural activities, people feel connected. And in this September, 50 traditional ships will get up from Nantes to Orléans, and wherever they stop, they will advertise a Parlement de Loire to give the river a personality. Next, please. But at the same time, we are losing this cultural connectivity in real time. So here on the left, you see from a PhD student, Raita Bala from Kinshasa, Congo Democratic Republic, how within one generation, just by plastic pollution, by siltation, by bad management of hydrosystems, people lose their love for the river, they turn away, especially the disgust from water pollution is a very negative trigger. And the next, on the right, you see here this, I interviewed this man, I have it here on my cell phone, a traditional fisherman from the Pantanal who is absolutely sure that the techniques that he learned from his forefathers will not be applicable to his sons, because the hydrovia is currently being built in Brazil, which is an absolute tragedy. The Pantanal, world's biggest wetland, is right at this moment about to be destroyed with the harbor construction. Here on the left you see already the soybean loading facilities in Cáceres at the upper Paraguay. And if this river will be straightened and deepened as we did 200 years ago with the upper Rhine, the Pantanal, world's largest wetlands with about 180,000 square kilometers, will be lost. And this next is for our greed. It's for transporting soybean, for transporting iron ore, which is actually obsolete because this canal will never work, and on the other hand, there is a railway underway, so we don't need it. Next. If we look at the relationship between human society and rivers, you have this simplified here on a time axis with up and down the traditional society, sometimes really having drawbacks with floods and droughts, and then early industrial, next. And then we have a point where the pollution strikes so hard that in many countries people begin to restore their rivers. In the case of the Rhine, it was the 1st of November, the catharsis moment, when due to a chemical spill accident from Sandoz in Basel, thousands of dead fish were floating at the water surface, and this was a starting point actually for the European Water Framework Directive, and some years later with the floods, also for the Flood Directive. Next. But the question is, with climate change especially, will this catharsis moment maybe hit us too hard? So we have to be proactive, we have to avoid that this catharsis moment happens. Next. And I asked several people, Shabas is here during this consortium meeting in Wuhan, the Great Rivers meeting 2018. How do you live with your river? And in following to this Wuhan conference, I could convince about 124 authors from social sciences and from natural science. How do you live with your river? What are the drivers for biology, for culture? What are the menaces, and what are the initiatives? And you can download this for free. And just yesterday I learned that the book will be printed. Thank you very much, Shabas. I'm really looking forward to see this. Next, please. The river culture concept is a concept to bring science into society. So we first have to work on our valuescape. We have to revise our values, not only return on investment, but also give the natural structure of the river a value. We have to develop kinship with the river. River is, so to say, family, and we have to feel compassion with the river when it is getting polluted, and not just turn our backs to it. So living in the rhythm of the waters learning from traditional societies that have been living. Johannes is here, who has been living in Manaus for a while. 12 meters inundation every year and not a single fatality, because the people just know for thousands of years how to live with the floods and the droughts. And we can also learn from the biota. And lastly, the bassin de responsabilité. We have to overcome the problem that rivers with their elongate form are cutting territories. Humans want to have a territory. Look at the development of France like an onion. It was growing around Paris, and that's the ideal shape of a territory. But the river is cutting it, or the river is dividing territories, and we have to overcome this. The river is in the center, and the hydroscape, the waterscape, has to become the unit, as the French Agence de l'eau are already showing how this is possible. Next. And so to identify this valuescape, we have to map it. We have to find out where are the people, where can we take them at the same level. We cannot do top down and just let them know what we are about to do with them. And my Chinese student Yijin Kao is asking how do you want your river? And she does this with a global network of water museums, and she works also with artificially generalized pictures. And next, we have a lot of different types of society, sectors of society, and each of them have their specific level. I'm going to talk about these individual motivation strategies tomorrow in my next talk in the morning. Next, please. So living in the rhythm of the waters, beginning with the flood pulse concept, actually transforming this into human adaptations, the availability of resources that can be used. So floods and droughts have something positive. They are not only catastrophes, but we are just colonizing floodplains and high-risk zones. And then the consciousness of this risk and the new definition of commons. So integrating the right of nature into this decision-making and redefinition of space. We have to get out of high-risk zones. And the reinsurers like Munich and Zurich Re are urging us, because real estate prices in the cities are sinking where the risk is too high. Next. Transform traditional use forms like fisheries, like boat architecture, and more recently river bathing. We can reintegrate these cultural activities. Next. And next. So learning from animals, for example, the millipedes in the Pantanal, new species here, they just go up before the water level rises, or the ants in the Loire River, they're building waterproof houses. Next. And then top-down meets bottom-up. Maciej has mentioned this in his talk. In Kerala, in India, they have restored 70,000 kilometers of stream with a local government that works together with the local population, and the population vice versa with it. Result of my PhD student Alvin Basail. Next. And we are very often producing negative feelings with this bad news about climate change, biocide, and so on. We have to produce enviro positivity with activities like this fall school that we did last October. And now my last slide, you can click 4 times, I believe. So we have a new master which will open its gates next September. And it is not only about the understanding of the biophysical problems, pollution and so on, and the restoration, so the engineering part, but also analyzing the social structure, the society, the decisionscape, I would say, and the communication strategies that are targeted, so that these people, we call them nexialists, can really implement their solutions. They are, so to say, professional troubleshooters. Next. And this is again, if you want to download the book. And I'm saying thank you for your attention.
Thank you, Professor Wanzan, for highlighting very interesting cultural perspective on river management, in connecting people with people also, and community participations. And they call it as river culture concept. So, sorry, from from cultural perspective, we are now moved to scientific perspective. I would like to invite the next keynote, which is Mr. Antonio Donato Nobre, the scientific director of the Biotic Farm Greening Groups. Please welcome.
Hello, good afternoon. Thank you very much for the opportunity, especially the fact that you opened this space for us to bring a message here. I'm new to this community, so a little bit intimidating for me to bring this concept. Can you start this? I proposed to bring here a message from the cutting edge of hydrometeorology, where I am active and our group is active. I have been involved in research in the Amazon for all my career, basically, and we developed a concept which became very popular, the flying rivers concept, and also more recently the biotic pump, which I will talk a little bit today. And I am talking this, the elephant in the room of climate action, because I'm growing very anxious with the fact that following the discussions around climate change since the beginning, in the 80s, 90s, I see little progress, even though we've seen in the first two speeches that there are many prospects for good development. Brazil will host the COP30 next November in the Amazon, actually. And the news from the frontier are not too good. And I am hoping to bring here a different perspective. It starts, the second slide, please. It starts with a very simple concept. No, the previous one. Yeah, very simple concept. The one that drives the core, the physical core of atmospheric models, which is the temperature-induced atmospheric dynamics. And this is very intuitive. When you have surfaces getting warm, it heats the air in the lower troposphere, the air becomes less dense, and then you have hydrostatics who pull this air up, producing convection. This is intuitive because you know the concept of hot air balloon. You have a hot air balloon, it rises, right? But now, next slide, please. We go to real circulation. There is an animation. This is an animation done by NASA, high-resolution cloud simulation of Australia. And you see clouds forming all around Australia and dancing, lots of fresh water, lots of rainfall. But what happens? This water that's there never breaks into the continent. Why is that? The question is, how come that the hottest surface on Earth, which are deserts, are not producing convection over deserts? This is a question that anyone should be making. I did this question like a child, like 5 years old, inconvenient truth. And I started asking because I have two brothers who are meteorologists. One is very famous, Carlos Nobre, I don't know if you heard of him. And I asked them, meteorologists, I said, what happened? Oh, there is this high pressure here and then movement there, and very complicated explanations which do not explain really. And now you go there and you say, you have a hot surface and the air is falling. Dry air falling over deserts. And this is an explanation why the wet, moist air around Australia doesn't break in. Because you have air moving from land to sea. It's a breeze from land to sea. This breeze, this dry air, doesn't allow moist air to break in. That's why you have a landlocked circulation over desert. Now, why is that? If we have this hot air balloon paradigm, why the deserts are functioning the way they do. Next slide, please. No sound, right? No, you don't have sound. Can you start again? Can you start again? Start again.
There's a small amount of water boiling in the bottom of this container. Now, when the water boils, it turns from a liquid into a gas, and as it's pushing all the air out of the container. What you're seeing here is water vapor. Now, to make it a little easier to see, I put this black straw in a stopper. This goes over the top like this. You can actually see it coming out of the top. Now, I've got a way to be able to prove to you that there's no air inside by allowing the outside air pressure to push this water up and into the container. So this cold water is here. Watch what happens when it goes up the straw. As soon as it hits, it fills the entire container. Look at this. It's the outside, isn't that cool? The outside air pressure.
So, did you see what is happening there? This is YouTube. This professor is a popularizer of science, educator. What he's showing is a basic phenomenon. PV equals nRT. It's the ideal gas law. Everyone learned in school about this. Nonetheless, the bulk of meteorology missed it. Why? What is happening around Australia is precisely what is happening inside this bottle. You get water evaporating from the oceans, and then it condensates. And when it condensates, it disappears from the air. When it disappears, PV equals nRT. When it disappears, lower pressure. When it lower pressure, it pulls air from the continent out. And that's the explanation why you have a desert. That's the explanation why air doesn't rise over dry land. Now, dry land, next slide please, has been on Earth, on the continents, for 4 billion years. Plants were invented only 470 million years ago. The Ordovician time. They climbed out of the sea. You see here this fantastic animation done for using tracers for water vapor. The color one is the one that went through the forest, the vegetation. The white one is the one that comes from the ocean for the Amazon, and this is something we've described and explained and developed the theory. It's called the biotic pump theory. And what is happening there is exactly what I said about around Australia and around other deserts in the world. Amazon is not a desert because it has plants, not the other way around. This is a key point to understand. And this is with data actually illustrating this wonderful functioning of the trees. They release water, water condensates, and then lower pressure pulls moist air inland, feeding the water cycle inland. Talking about enhancing the water cycle I got from the first talk. That's how you enhance the water cycle. You bring it from the ocean. Next slide, please. And how does plant do that? They have this magical fairy dust, terpenes, isoprene, and a whole lot is spores from bacteria, fungi, pollen grains, a whole host of cloud nucleation, cloud condensation nuclei that plants release. In the Amazon, we have been studying this. There's a lot of studies done by the Max Planck Institute, collaboration with us and other groups in the US as well, showing this miraculous mechanism in which trees promote the water cycle. Because having water vapor rising in the column is one thing. Having it condensating at 4 kilometers in height is another thing. That's the key, condensation. Now, what happened is last December, there was a paper in Science by Goisling saying that there was an explanation for the acceleration of warming. I don't know if you saw it. And they basically mapped cloud cover. And they saw that cloud cover is diminishing. And that's the explanation for the warming. It's speedier than any model predicted. And where the cloud cover is diminishing, over the big forests. The Amazon, Canada border forests, and also elsewhere, Congo and the big forests. And the paper failed to point to it. So we wrote a note, and just came out last week in Science, speaking about this. What happened in the Amazon? 2 years of drought. So when you have a drought, the trees stop doing the biotic work. They cannot function anymore properly. And Canada, there were massive fires in Canada. So this is basically the fact that this is what is saying plants make the hydrological cycle on land. They're not only subject to the feedbacks from climate change and hydrological change. They are the promoters of. Next slide, please. Now, if you see this map of vegetation covering land on Earth, plants conquered all the continents, even the deserts. There are many works showing that Saudi Arabia 12,000 years ago was the Garden of Eden in the scriptures, right? The pharaohs from Egypt, they crossed the Red Sea to log big timber. And now I go in Saudi Arabia, you don't have a river flowing. I was telling to our friend from Germany that if you don't have rainfall, you don't have wetlands, you don't have rivers. That's what we are doing. We are changing, like happened in Saudi Arabia, like happened earlier in Australia, and even in the Sahara. We are building deserts by destroying vegetation. This shows the vegetation around the world. You see there are no covered deserts and ice lands. Next slide, please. If you look to productivity, which is the intensity, like let's say the biosphere GDP, the net primary, or the gross primary productivity, you see that the tropical band is the most important carbon engine. But if it is a carbon engine, it's also a water engine. And water has everything to do with energy. Every gram of water evaporated consumes 600 calories. So water evaporation is cooling. Much more important than CO2. Much, much more important. Next slide, please. This is an artistic piece done by Yadvinder Malian group in Oxford University. And the morphing of the continents tell you every frame is a different date, 10 years data set, showing the relative importance of those ecosystems in the whole of the biosphere. Again, it's photosynthesis, but it can be read as also engine of water energy. So you see that if we lose the Amazon, it's not only a loss of biodiversity, which is dramatic and terrible. It's not only a loss for the South American countries, it's a loss for the whole planetary system. I have emotion when I talk about this because it's really dramatic what's happening. Next slide, please. So in conclusion, land plants are crucial to the freshwater cycle. I would even say land plants invented the water cycle on land. If you don't have a plant cover, land will be a desert because this is the equilibrium, geophysical equilibrium, as I explained. Because you have water, you have land, mineral landscape, right? And then water produces condensation around this mineral landscape, pull air from it, dry air comes down, and you have a desert, landlocked desert. Plants were very ingenious. They invented a way to break the cycle and produce a water cycle on land. And attracts water, controls carbon, of course, cools the surface, as I said. A big tree in the Amazon is equivalent to 3 big air conditioning units, like 36,000 BTUs, and regulates climate. Next slide. What are we doing? We are building deserts right now. And we are too concerned with CO2, which is important. CO2 is 20 to 22% of the forcing warming. Water vapor is 60 to 80%. No one is talking about water vapor. And trees and forests and vegetation in general, wetlands, they're incredibly important to the water cycle. Next slide. This is the Amazon River, one of the branches of the Amazon River last September. What are we doing in the Amazon? We have done in Saudi Peninsula, we have done in Australia, we have done in Sahara and other deserts. We're destroying the water cycle on one of the most beautiful, rich biomes on Earth, the Amazon. And we are seeing the same phenomena happening there. The eastern part of the Amazon is drying up. Why? Because of being deforested. People say 20%. They say 40 to 50%. Because forest degradation is also, it renders the forest unable to fulfill this climate role. And we see the same thing. Air is no longer, convective is no longer going up, it's coming down. And produces what I call the sitting pachyderm, elephant over South America, produces a bubble of hot air trapped down, doesn't allow the cold fronts from Argentina to come in. When they meet in between, produces floods, like happened in Rio Grande do Sul last year. And when they sit there for a long time, then you don't have rainfall. And then you kill the forest that's still there. Next slide, I think. Just 2 slides to conclude. The familiar narratives that you have CO2, you are warming Earth, right? Going up in the warming. If you have more CO2, you go higher. That's widespread narrative. And the new narrative that we need to consider is that when we embrace nature, when we cultivate the biomes, you create a less sensitive system for CO2. So if you don't have the nature, then whichever CO2 you have produces a much stronger effect. So that's it. Thank you.
Okay. Thank you. Thank you so much, Professor Antonio Donato Nobre, for interesting point of view on related to vegetation and the land of water cycle, and also the specific concept of flying rivers, which is interesting to be explored together. And I hope these 3 keynote will be as a setting stage for the next panel discussions. So I would like now to call all panelists to be on stage together with me. First panelist, I think Andres is not here. Okay, the second, Mr. Johannes Koban, to be come over to the sitting here together, and then Professor Salbaskan, Director of UNESCO Beijing Office, and Mr. Benjamin Lopez, please come forward, and then Professor Michelle Musa from IHR, and also Dr. Omok Bemi Oyaya, Director of Regional Center for Integrated River Basin Management, RCIRBM, under the auspices of UNESCO in Nigeria. Okay, so as highlighted by Prozalewski, which is interesting to be at this today's panel discussion, UNESCO is already almost 30 years implementing ecohydrology. So this is also can be as a setting stage of what we can do further later in the future. And then also on the cultural perspective and scientific perspective for related to ecohydrology. So then, therefore, I would like for this panel session, we identify 2 main questions that to be answered together by each panelist. The first question is related to what added value transdisciplinary ecohydrology has been providing to the ISP and water sciences. And then the second one is related to what should be the synergies of transdisciplinary ecohydrology with water, environment, and sustainability science. So I would like to invite the first panelist, you want to comment to give perspective?
Yeah, thank you, Beauty. Thanks for inviting me here. I think ecohydrology has been essential in making us aware that we cannot really address societal or economic challenges with the old school traditional way of how we try to engineer our environment in the past. And I think that's the biggest contribution that ecohydrology has brought to our awareness, and the IHP is the condensation channel or so for that, but really has contributed, I think, to the wisdom of our societies in that regard. So there is a huge positive impact that all the people that are in this room have created together. But for me, the more interesting question is, where do we go from here? Or what is the perspective? And I think Maciej has mentioned the cycles, and I have worked for some years with some of the cycles, energy and carbon mainly, and water, and those three plus the nutrient cycle, I think, are for me the engine where ecohydrology in the coming years can determine at those intersections of those cycles where are the synergies or the positive externalities that we need to focus on, because we cannot resolve the challenges we face with upscaling of traditional solutions. We need different solutions, and the different solutions, one of the keys to the different solutions lies in the socio-economic benefits that are inherent to the intersection or to the overlap of those cycles: water, carbon, nitrogen, phosphorus, and energy cycles. So I think that is one very important objective for our community to focus on. And because we are talking about cycles, it is related to the second message I want to give. We know that on our planet, many people are talking about growth, and it's green growth now, and it will be, I don't know which other growth in the future, but the growth paradigm only works if we have infinite resources, and we don't have that. So the big question is, how can we support societies in building more circular approaches to business, to behavior, to culture? So the circularity issue, I think, is a crucial question on the way to sustainable development or resilience or whatever you want to call the post-2030 agenda. So there is a big challenge, but also opportunity for ecohydrology to focus on where can ecohydrology support circularity in economics, but also in our thinking. And I'll stop for here now. Thanks.
Thank you for sharing that, Mr. Coleman. So I would like to invite the next panelist, Professor Sahbaskan, who have been involved with this program, Ecohydrology program, for more than 20 years.
Long time.
So you must have more specific value on transdisciplinary ecohydrology. Please, the floor is yours.
Thank you, dear Dr. Al-Fitri. From me, congratulations again to you for organizing this symposium, but also to be a coordinator of the ecohydrology program. I joined UNESCO in 2008 as a secretariat member. And one of the challenges for us was to put ecohydrology back on track. That was a challenge. And there is a reason which I can explain to you. Because different people have different thinking about what really ecohydrology means. Hydrobiology, hydroecology, ecohydrology, what does this mean? And ecohydrology in the context of IWM, that's a question. The first question I asked when I met Professor Zelwiski, is ecohydrology IWM, or is it replacing it, or is it a tool for it? And our consensus from the figures today was also it's a tool for it rather than it's replacing IWM. That's how we started. And I'm always fascinated by this very important figure which Professor puts, different scales of the river system and then the metabolism associated with it. I think that's the most fascinating process which I learned, and then linking with bivalves and in Portugal. I have a presentation if that can be uploaded, otherwise I can just speak. Dear Al-Fitri, there was a presentation. So now the value, I think, for me as a scientist professor coming from Australia was ecohydrology crystallized the concept of how do we work with the lakes, with the rivers, with the water bodies which desperately need to be conserved, restored, or enhanced. That's where the challenge was. So that's where this concept of dual regulation, and learning from the professor Lilvisky, I've been a professor of hydrology myself, so that was really something. As a water professional, you learn something what science offers. And I went to Poland and we saw the lake system being restored, and then the blue-green network. I think that's the value. That we have proven the value that dual regulation works. And as it works, it can have benefits for policy. It can help change the landscape of a city, where we have this. So that's where I would say the first part. But I think I must also be very frank with you. I have very high admiration for professor, but I also say it's complex. We get bored with ecohydrology because it is very, very complicated from a scientific perspective to explain to the common people. And I'm sure Giuseppe will agree with me. So from 2008 to 2012 it was me. And then Giuseppe took over. And from Giuseppe it came to Al-Fitri. So our criticism, dear professor, I must tell you, at the 50th celebration, we get bored with it because it's very complex for most people to get it, what it really means. So that's really one of the challenges we have been facing, and what do we do with it? So finally, there is Journal of Ecohydrology, and it's elsewhere, it's doing well, and UNESCO has contributed to it, and all of you have contributed to it. Now look into society, environment, and economy. My brother Johannes has mentioned about circular economy, linking with that, but also politics and culture. When I went to Indonesia, where Giuseppe was working at that time, we set up APCE, Asia Pacific Center for Ecohydrology. To them, ecohydrology is very different than what it means to you. Let me be very frank to you. They are limnologists. They're not hydrologists. And the leadership which came was very different. And also they are Muslim people mostly. And they have a philosophy to link. So that's very important for us to learn how APCE adapted to ecohydrology. You come to China, it would be completely different. So let me introduce this concept. We need to tailor ecohydrology to the needs of society. I went to Portugal. Ecohydrology means something different to the people which are political people, and we were setting up a center there. And with the University of Algarve, finally we have a chair. So we need to make it more and more relevant to the needs of that particular country. Indonesia, ecohydrology need to be customized. China, ecohydrology needs to be customized. Same is with Central America and so on. Next, please. It doesn't move. Okay, so Professor Wanjan has given an excellent overview about bringing culture. I would say there must be a paradigm which holds things together. In China, we have this eco-tradition. From Confucius, unity of nature and human. You are also talking about it. Professor, you are also Confucius of hydrology. Taoism is the way being modeled on nature. Buddhism, all living things are equal. You think about these paradigms, and now President Xi Jinping has a thought about ecological civilization. I think we need to think about the politics and the policy frameworks. So next, please, because the time is limited. I strongly believe that policy should be the steering wheel. Policy, whether it's Indonesia, whether it's Portugal, whether it is Pakistan, whether it's China, policy will be different. We need to carefully think. But the center of it is eco-biotechnology. So whether there are special plants or whether there are bivalves or there are other technologies, and then it is linking with education and culture. Next, please. So in China, I would like to quickly introduce to you this river chief system. It's about getting rid of pollution and making people responsible at various levels. It was introduced only in 2007. By 2017, it has been officially launched in the whole country, and many of the polluted rivers and lakes have been restored. I quickly show you one example. So we need to take eco-hydrology concept and its implementation to the level of the river chief system at various levels. And you can take this approach to Indonesia, to Pakistan, to other countries. Next, please. Whether it's European Framework Directive, for example. Next, please. So this is one example of Lake Hongfen. It's a very big lake. It's a 57 square kilometers in Guizhou city. So it's according to professor's terminology, it's at least a medium to large level ecosystem. And it was a place which was extremely polluted, serious issues with the fishing, people bombing to get fish out. There were serious issues of pollution. It was surrounded by polluting uses, and then there is a transformation which has happened. Next, please, very quickly. So dual regulation, Chinese have understood it for a long time, and we have a Chinese Academy of Science Center working on it. There are papers on eco-hydrological biotechnologies. There are papers on phytotechnology, environmental flow, water security, water. All of this knowledge is there. But only one thing has materialized, this to gel together to make things happen. That's the ecological civilization and this river chief system. So you bring that all of this knowledge, link it with the policy and implementation. Next, please. And you will see the difference. These are photographs of extremely polluted this lake and the kind of unsustainable development on it. And then there are interesting statistics given that I made a picture when I arrived in China. Next, please. This is the party secretary of the area. You are working with them to understand, and you have scientists who can understand eco-biotechnologies better than anybody else. And there are real estate developers. They need this area to become pristine. Next, please. And this is what you achieve. Not just because of science. So science is there. So science is going on for a long time. Biotechnologists are there. The people working on environmental flows are there. Ecosystem people are there. But once it comes together with the right policy of ecological civilization and the targets given to these river chiefs, if you don't achieve your part of the work, there would be stick and there would be carrots, maybe more sticks than carrots. And then in the end, within less than 5 years, the area is enhanced, not just restored. I think that's where our challenge is as the next step to take eco-hydrology, not just a scientific realm of achievement, but how do we make things change and how do we turn our rivers, our lakes, our extrine systems to work together. But thank you very much.
Thank you so much, Prof. Sabas, for the perspective on interesting concept also. I think on the level concept of the level of river chief system, this is very unique at various levels. So this is also the one that we implement also like at the catchment level currently for ecohydrology at the river basin, at the lake, at the coastal area. Thank you very much. So now I would like to invite our next panelist from Water for All, Dr. Benjamin Lopez, to share their involvement and initiative related to ecohydrology, which I think they call different way.
Yeah, thank you very much. Thank you for the invitation and for giving us the opportunity to hear from this very inspiring previous presentation. I think this is really important. How to enhance ecohydrology in our domain, in the fresh-related domain. Maybe one way is to create spaces where scientists can share their experiences, where they can discuss with stakeholders, where citizens can also hear from research results, etc., etc. We need to create some spaces, and I think this is what we are doing in Water for All. This is a European co-fund partnership elaborated under the Horizon Europe program, and you can go to the next slide, please. This partnership started in June 2022, and we put together 90 partners coming from research ministries, funding agencies, research organizations, but also European networks, local authorities. All these stakeholders are working together to think about what can be the future of freshwater-related domain. This is important to have all these people reflecting with their point of view on the same domain. We are 33 countries, 23 from Europe, and 10 right now that are non-European countries. Next, please. We are all together elaborating a research innovation agenda covering all fresh-related domain from sources to sea in an holistic approach. And you can see we are elaborating our agenda with 7 core themes, and you can see that the second themes, it is directly linked with ecohydrology. This is the water for ecosystems and biodiversity. This strategic research and innovation agenda is the backbone of Water for All. This drives our activity, and we try to develop sound research, transdisciplinary, but also transboundary research, creating some pan-European and worldwide consortia to address this question. Next, please. In Water for All, we are developing research with transnational calls, and we are launching annual calls each year from 2022. The second call we launched was on aquatic ecosystem services, so directly linked with ecohydrology, and we funded 23 projects with this call for a budget of 27 million euros. So we are developing some research with this kind of calls, but we are also carrying some additional scientific activities to identify research gaps, research needs, and what it is important is that stakeholders are participating in this kind of activity. They are expressing their needs to the researcher, and the researcher try to answer that, and this is not easy to make a discussion between researchers and end users, but we are trying to do that with some instruments. We are also working to support SMEs, to support the innovation business. We are developing living labs, etc., etc. Next slide, please. Just a small focus on the 2023 joint call, Aquatic Ecosystem Services. I said that we financed with that 23 projects on 3 main topics: the mapping, monitoring, and the assessment for a better understanding of ecosystem services in context of changes from local to global changes. The second topic was understanding and predicting multiple pressure, impact and responses relationships in ecosystem services, and the third one was on the new tools and solutions for better integration of ecosystem. If you want to know more about that, we are providing a booklet of all these projects with a summary, and you can download this with the Water for All on the Water for All website. Next, please. For this call, we launch a knowledge hub, and this is a place, this is a space where stakeholders can speak with researchers, and where researchers can try to better explain what they are doing to transfer their results, and we try to facilitate that, to foster this transfer from the research results to the end users, citizens, policymakers, SMEs, etc., etc. Next. Just like an ad for the next call in 2025 in September, we will launch a call on water and health. So if you are an organization, research organization, pay attention on that. Water and health, water and One Health. So human health, but also environmental health, river health. So ecohydrology is welcome in that kind of call. Next, please. So I want to do just two focus. We have plenty of additional activities to engage scientists, to transfer research result to policy, to connect problem owners with solution providers, to communicate with society, to educate young people, to increase international visibility. Plenty of things. Two, I think are quite interesting in this session. The first is our thematic annual programming action. We are clustering some national projects on different domains, and the first one was on water and biodiversity. And we have a cluster of national projects dealing with water and biodiversity. This tab called AquaWise, and you can find information on that also on the Water4All website. And the second one is the water-oriented living labs. We have 21 living labs now in Water4All in maybe 12 different countries. And these are a good place for experiment, demonstrate nature-based solutions, innovation in governance aspects, etc., etc. So this is something important. Next, please. I think we share plenty of ambition with UNESCO. That's why we signed in November 2024 a memorandum of understanding with UNESCO, and we are working now, starting work to make this ambition concrete, and we are plenty engaged in the same objectives and ambition. So. If you want more information, we have the website of Water4All. I recommend you to subscribe to our newsletter. We have some video, and you can download the booklet of the research project for the two first calls now, and you will find some information, notably on aquatic ecosystem services. So thank you again for the invitation, and thank you for your attention.
Thank you, Benjamin, to share the initiative by Water4All, which is also related to ecohydrology on aquatic ecosystem services. So next panelist, I would like to invite Professor Michel Mossa, representing IAHR, which also work very much in a similar initiative, which is ecohydraulics. So we would like to hear from maybe next.
Waiting for the starting of the presentation, first of all, I would like to thank the organizing committee for having invited me to be here today. Just to let you know that today I'm not here as a representative of my university, which in any case is the Polytechnic University of Bari, but I'm here on behalf of the IHR. I have the honor to see here the executive director of the IHR, Dr. Tonsu, and also other people of the IHR. And so one of the most important aspects of this presentation, as already shown by Professor Maciej Zeleński, is to try to stress, because we have already cooperation between ecohydrology and ecohydraulics, is to stress this cooperation. So again, what is AHR? AHR is an acronym which, as you can see, stands for International Association for Hydroenvironmental Engineering and Research. It starts its activity from 1935, and it's a non-profit association which works all around the world. We have 2 seats today, one in Spain and the other in China, and is involved in all aspects of water engineering and water science. Next slide, please. Okay, nomen omen was said by Latin, so ecohydraulics derive from the merging of the 2 words, which are ecology and hydraulics. The word ecology stems from the Greek oikos, which means, of course, house and environment, and then hydraulics is well known fluid mechanics. So ecohydraulics refers to all the science part of water engineering and water science, where we have an interaction between ecology and the fluid mechanics. Next slide, please. When I try to write a list, there is always the possibility to forget some points, but nevertheless, the most, in my opinion, key areas of ecohydraulics research are flow vegetation interaction, mainly in coastal and estuarine areas, problems regarding diffusion sedimentation of pollutants and nutrients, and we have already listened to the previous keynote lectures of this session. Particularly important are the nature-based solution. In my case, for example, for the nature-based solution for coastal defense and also hydrogeological protection. A large group of ecohydraulics are mainly devoted in the design of biological corridors, for example, fish passages, interaction between hydrodynamic, ecological, and geomorphological processes, development of renewable energy from marine flows and wind, and then, but not the last, monitoring, managing, and restoring of aquatic ecosystem. Next slide, please. Of course, these are only examples, for example, regarding the coastal defense, nature-based solution, and also soft solution, which are a bit different from the previous one. And so, in conclusion, the importance of interdisciplinarity and cooperation between ecohydrology and ecohydraulics. Next slide, please. For example, in this slide, we can see how urbanization of the coast has turned coastal erosion from a natural phenomenon for which we have an alteration between a creation and erosion into a problem of a growing intensity, where, for example, the solution proposed, such as there's the report at the bottom of the left part of this slide, is worse than the problem, creating the so-called squeeze problem. Next slide, please. We have also already heard in the previous presentation the importance, which is one of the main focus of ecohydraulics, of interaction of vegetation and fluid flows. In fact, particularly important is the role of vegetation in estuarine, the coastal zones, but also in rivers, and it depends on the scale of the analysis. For example, also the absorption of nutrients from a single stems depends on what fluid mechanic experts call the boundary layer that is formed on the single stem. But growing and arriving to the scale of a marsh, particularly important are, for example, problem of retention or no retention, release or no retention of diffusion and advection aspects of organic matter, tracer, pollutants, and sediments. Next slide, please. Okay, this slide, it's very similar to that of the third keynote lectures. I didn't know it, but here we can say one of the most important nature-based solutions, which is based on the preservation of riparian vegetation, for example, marshes and mangroves. Marshes and mangroves are particularly important, for example, because they naturally reduce coastal erosion by damping waves, and specifically, particularly waves such as dramatic waves, such as, for example, tsunamis. And furthermore, we have already listened that they are also able to combat climate change by sequestering a substantial quantity of carbon in the subsoil. Next slide, please. Okay, these pictures are not mine, they are derived from the paper by Patel et al., whose reference is reported at the bottom of this slide, and which reveals some dramatic images which refers to the Sumatra tsunami of the year 2004. But what is important to underline is that the study of these authors observed that some of the houses were preserved because of the presence of coconut trees. So again, the importance of this nature-based solution and the preservation of our environment, which again are one of the main topics of ecohydraulics. Next slide, please. Okay, we have already said that we are in the One Health range. What I mean is that, of course, the human health depends on animal health and environmental health. We have already heard this in the previous comments. Next slide, please. Okay, another topic on which the group is working with other people of IHR is that of renewable energy. These are some of the renewable energy which are defined by the United Nations. Of course, we are focusing our attentions on renewable energy where there is water, or where there is flows, for example, winds, or for example, ocean energy. Next slide, please. Okay, another aspect particularly important on which IHR has been working for many years is also the creation of a network between huge, very huge coastal engineering laboratories. For example, Hydrolab Plus. This is, for example, my huge coastal engineering laboratory, but there are many others all around the world. And these are particularly important in order, for example, to carry out specific action in terms of research and scientific development in the correct direction, which in the time that I have at my disposal, I hope I have told to you. Next slide, please. It's important to underline that sometimes it's not possible always to solve the problems using the so-called nature-based solution, but it's sure we can, for example, avoid the squeeze effect that I have already presented in the previous slide using the so-called soft solution. Soft solutions are solutions which, even though are not nature-based, they are not so with so great impact. For example, with the use of metamaterials. As you know, metamaterials are materials that are arranged like an array, like in a patterns. In this picture, you can see one of the research that I'm going to carry out with many other universities, and which refers to the use of a pendula, a buoyant pendula, which oscillates with the arrival of waves, and so they could, in some situation, also give wave damping in a good way in the soft solution and without having great problems for the environment. Next slide, please. These are some of the activities that have been already done and others have been carried out today. Okay, don't have much more time, so next slides again. Some recommendation, which is the first part of the work that thanks to host the group of UNESCO and also Ecohydrology have already said. For example, we must promote transdisciplinary water management. We must implement advanced nature-based solution or also soft solution. We must shift governance paradigms. We have already listened to this point. We must use big data and we must use artificial intelligence in good way also for the environmental monitoring and others. Important is also the design of an ecosystem-sensitive infrastructure, again, support renewable energy integration. And as was already said by other people previously, we must also educate the new generation. And so another aspect that IHR is carrying out is education and also engaging stakeholders. The other slide, please. Okay, this is a picture that I have constructed with Professor Maciej Zeleński, and it can summarize, maybe not all, my presentation. In summary, it's absolutely important cooperation. It's important to have a cooperation between different expertise, and in this case also between ecohydrolysis and ecohydrology. The last one, slide. Okay, I have also prepared for the people who are interested this link that is www.michelemossa.it/link_video, where you can hear, if you have a time and you are interested on, for example, this presentation, but very deep, that I had the chance to present as a keynote at the Clarkson University in USA. And you have also the possibility to see the presentation of the two huge coastal engineering laboratory that already said are particularly important in also a scientific point of view, for which also it's important to underline that all the solution must be science-based, and so also this aspect is particularly important. Thank you very much for your attention.
Thank you, Professor Musa, for highlighting the synergy between ecohydrology and ecohydraulics, and providing some recommendation, which is very much important and useful. So we will move to the next and last speaker, but not least, of course, Professor Dr. Omogbemi Yaya, the director of RCIRBM Nigeria.
Thank you very much, Dr. Efichi, and ladies and gentlemen. I want to appreciate the opportunity to showcase our efforts at ecohydrology in the West African sub-region. Actually, the journey started some time ago, and we had Professor Zaleski helping us to develop a capacity, and that has been an asset to us now. And we have been able to use that capacity to expand and popularly introduce the concept of ecohydrology as a tool that is capable of addressing environmental challenges. I have some slides. So now we started with Jabi Lake, which is in central part of Abuja, the capital city in Nigeria, and that lake we discovered has been massively compromised, and it presents a very ready example for us to apply the ecohydrology tool, and equally use it. We actually plan to use it to not only demonstrate ecohydrology, but equally as a research hub for institutions. But the cooperation we had from government and the agencies that are managing the lake was a bit weak. But be that said, as it may, we were able to achieve some level of success. And when we discovered that it was a bit more difficult for us to get their cooperation, we extended to River Ethiopia. So for River Ethiopia, in Niger Delta, yes, next slide, in Niger Delta area of Nigeria. These are just to show what this regional center, which is pioneering ecohydrology in West Africa, is all about. The establishment and the structure. Yes. Next slide. Yes, next slide. Objectives, and yes, it's normal for us to. Yes, next slide. Objectives. Yeah. Actually, the 15 West African countries are our areas of coverage, and as much as possible, none of these countries has not heard of this ecohydrology, which is through the regional center. Yes, next slide. Next slide. The regional center itself is the African hub for 3 UNESCO flagship initiatives. That's the ISI, International Sediment Initiative, International Initiative for Water Quality, and HERP. As you may know, that tomorrow too, revocation of HERP will take place, and the regional center is giving a backup to the center in Dundee for that event. Yes. Yes. We have built a lot of international partnerships over time, and that is one of the things that makes us to be able to have ready access to those to invite for either for workshop and capacity to mobilize for for training. Then these are just highlights of the various hydrological activities that we have embarked upon since inception, and just a highlight. Yes. See, continue. Yes. Now, this I just put a demonstration of a practical demonstration of what we have actually, how we have impacted the sub-region by propagating the hydrological approach as a tool for enhancing water quality in West Africa. Yes. This was, yes. This is in Cape Verde. It was a national meeting. We had already done I introduced the concept and the approaches in prior, but this is Mayo Biosphere Reserve, where we are trying to practically demonstrate how eco-hydrology can be used in that reserve to address some of the environmental challenges. And by that, we're able to equally train deliver local capacity for managing the reserve. Yes. This was an event of eco-hydrological training event in Abuja. That's our honorable minister, and we had to make sure that we did it side by side with World Rivers Day, because the regional center, in 2020 introduced Nigeria to celebrating World Rivers Day as a way of addressing some issues. So our honorable minister very passionate about eco-hydrology, and the permanent secretary were there, and Dr. Efichi was there too, and some other West African participants. Yes. This was in Yamoussoukro most recently. It was in April in Yamoussoukro, and we were able to introduce the concept, the approach, and they took us. They have about 13 lakes there that are highly compromised, and we went around them, Lake 1 to 13, and we were able to profile them, and we have chosen 9, Lake 9, as where we have to demonstrate eco-hydrology and later present it for approval by UNESCO. And I think they are very cooperative and they are very embracing. Yes, this is still part of the sites at the lakes, at the 13 lakes in Yamoussoukro. They have about 25 lakes, but 13 we chose for extreme issues. Yes. This is River Ethiopia. River Ethiopia is in the Niger Delta part of Nigeria, and we're shifting attention to that place now because it's it has had some international exposure before, and our going in fits in very, very easily. And we are trying to, they are trying to encourage us to see that they apply eco-hydrology to address some of their issues there. So yes, these are the stakeholders in River Ethiopia. We normally have a meeting with them before going to site, carry out a ecological survey of the site, profile it, and let them know which one they can adopt as a site for demonstrating and later present to UNESCO. Yes. This was this stakeholders engagement in Jabi Lake, and you discover that the two group photographs down, that is by Jabi Lake behind. Then that was the workshop, and that workshop was all the 15 West African countries, including the 5 regional river basin organizations, NBA, OMBS, OMVG, they were all there, and even the ECOWAS Water Coordinating Center here in Ouagadougou. So these are just to show us the efforts that the center is actually making to popularize eco-hydrology and use it as a tool in West African sub-region. Yes. This is by Jabi Lake. This the entire group of all the 15 West African countries were represented by a participant, and it was in this workshop that the participant from Cote d'Ivoire was able to identify that they can use Ecohydrology as a tool in Yagbosoko, and she was very proactive and had to mobilize support, UNESCO Abidjan, UNESCO Dakar, UNESCO Abuja to support her, and we were able to have a successful workshop and mission, yes. Then this was in Abuja too. That was in 2022. This is the same workshop we had with World Rivers Day with the minister, but the minister could not attend this opening ceremony, but she was with us at the Jabi Lake site for the World Rivers Day and to flag off this workshop. Yes, this is just a picture of a typical, sites across Nigeria that require ecological attention. Yes. Then these are just to show us some of the meetings we have had in the past. Apart from ecology. Yes, that's one.
Because we are already
yes, that's the last one. Yes, next. Yes. Thank you very much.
Thank you so much.